The International Space Station's Expedition 36 and 37 is an increment filled with visiting vehicles and spacewalks, all on top of a packed agenda of scientific research.
The ISS today is pretty much the pinnacle of space exploration art, and it shows how many different countries, dozens of countries, engineers, specialists can work jointly on one project and to work reliably.
Some of the dozens and dozens of experiments are automated and monitored from control centers on Earth. Others require a helping hand from the laboratory assistants on orbit. Taking care of those human crew members is a top priority.
The most important purpose of ISS is to learn, to study how people can live in space, how to make their life there more safely.
And these crew members are subjects for tests designed to learn exactly how a human body changes during an extended period of time in space. Some of these tests can also have benefits for people who never go to space. For example, there's an experiment called Pro-K.
It's a very simple experiment, apparently, where we're going to look how a diet can influence the loss of calcium from our bones,
which could have an impact on the treatment of osteoporosis for people on Earth. Another is called Sarcolab.
We will be looking at how the sarcomeres, which is it's part of our muscles, how do they work? How do they interact? What happens to them when they're put in a condition that is different from what they're used to?
As in weak due to no gravity to work against, similar to the condition of someone who is bedridden. Another area of concern is ocular health, since it's been discovered that some crew members have been coming home with diminished vision.
And it's not known exactly at this time what causes this, but it's an important thing, especially if we're going to be spending longer and longer times. Will it get worse as the time goes on? And so they're really starting to do a lot of experiments with us, taking images of the retina, taking pressures, looking at your, getting eyesight checks throughout the mission.
The station crew is also learning about technology that can have an impact on the ground. For instance, crew members are proving the efficacy of using an ultrasound to examine the spine rather than an MRI.
But ultrasound is a very now inexpensive and can come in small briefcase size packaging. So that, in my opinion, would spread to lots of places on this planet that don't have the means and the financial wherewithal to get this expensive medical equipment.
Among these experiments designed to prepare people for deep space missions in the future are improved countermeasures to fight the bad effects of weightlessness, better exercise equipment and protocols that are already making a difference in mitigating bone and muscle loss.
Now on station we have very nice equipment. It's IRET equipment. It's physical training. It's like our gym. My second flight, it was a long flight on station in 2007. We don't have IRET, we have ERET. Yes, it's more simple. Yes, and I know about myself. From 2010, when I used IRET, my physical condition, it was more better than on 2007.
But that's not all. The station's several laboratories are also hosting research in a range of disciplines that is taking advantage of the lack of gravity. The Italian combustion experiment Green Air is one of them.
We will study its combustion in order to understand how to ameliorate, to make it better, so that the results of combustion, which normally are toxic substances, how to make them either disappear or reduce them to the minimum.
A lot of the processes that take place on Earth, as in fires, combustions of materials, solidification of materials, flow of liquids, all of that is highly affected by the force of gravity.
And all of that, along with Earth observation, technology development, and education, are being studied on this mission. During expeditions 36 and 37, the crews expect to greet most of the cargo vehicles that are keeping the International Space Station supplied. The fourth of the European Space Agency's automated transfer vehicles. the fourth H-2 transfer vehicle from the Japan Aerospace Exploration Agency, a visit from a Russian Progress freighter.
And we're also hoping that in the period of time that we're there, we'll get the vehicle from the Orbital Sciences Corporation, the Cygnus vehicle. It will be, potentially we will get their first demonstration flight. And so that would be very exciting.
All of that visiting traffic is scheduled during a very busy period for spacewalks. The EVA frenzy kicks off in late June, with veteran spacewalker Yurchikhin and first-timer Misurkin replacing a fluid flow regulator on the Zarya module, testing the station's Kurs automated docking system equipment, and removing an experiment from the exterior of Zvezda. In July, there are 2 spacewalks planned for Cassidy and Parmitano, who will become the first Italian spacewalker in history. The tasks for those EVAs include replacing a failed transmitter-receiver box for the space-to-ground communication system, routing power cables from the U.S. segment to the Russian segment to support a new Russian laboratory module being prepared for launch, retrieving scientific payloads, and relocating other hardware. In August, Yurchikhin and Misurkin go back outside twice. First, they'll concentrate on routing those power and data cables from the U.S. segment along the length of Zarya into position at Poisk to later be connected to the new Russian lab. And on the second EVA, they'll install hardware for a new optical telescope and retrieve science experiments. And then crew changes take over. In mid-September, Vinogradov's Soyuz crew departs. Yurchikhin assumes command for Expedition 37, and shortly thereafter, he greets the arrival of veteran cosmonaut Oleg Kotov and first-time flyers, astronaut Michael Hopkins and cosmonaut Sergei Ryazanskiy. After just 6 weeks together, they'll all be joined by cosmonaut Michael Turin and astronauts Rick Mastracchio and Koichi Wakata, who arrive only days before Yurchikhin, Parmitano, and Nyberg depart for a landing in Kazakhstan to wrap up their on-orbit part of humankind's ongoing effort at exploration.
50 years from now, we will use the science and the technology that we are creating right now. And that's why I'm proud of the very small contribution that I will be able to give in my 6 months increment, because I think that I will be opening the doors for future generations to be able to go farther away.